friends, welcome to Learn Engineering with Mira. Today we will discuss how to solve the problem of an inclined plane. We will find out resultant force acting on an object placed on an inclined plane as well as problem of equilibrium by all analytical methods available. So let's begin. Let's have a look at the first problem statement. Suppose a wooden box of mass 50 kg is lying loosely on a frictionless inclined plane or ramp and is sliding in downward direction along the ramp. So find out resultant force acting on the box as well as acceleration of box. The inclined plane makes 30-degree angle to horizontal. Let's first of all draw the free body diagram by considering all the forces acting on the box. First step in drawing the free body diagram is to see how many supports or other bodies are in direct contact to the box and if there are any external forces applied. As we can see, only the ramp is touching the box. So let's first of all find the reaction developed by ramp. As the plane of ramp is assumed to be frictionless, box can move in this direction freely under application of force. But the ramp prevents the vertically downward movement of box and so reaction will be developed in opposite direction, normal or perpendicular to the plane. Other supports like a wall or storage rack are not in direct contact to the box, so they can't influence any movement. Also, box is lying loosely and no additional external force is applied. So only one reaction from the ramp is acting. Next step is to locate the self weight of box. Self weight of object always acts in vertically downward direction and from the center of gravity of the object. Irrespective of the horizontal or inclined position of object or whether it is hanged by rope or lying on ground, self weight acts in the same way, vertically downward direction through the center of gravity. And this is the free body diagram along x and y axis. Drag the reaction force in upward direction without changing angle so that the tail of both forces meet at center. You can always find resultant force by considering this classic vertical and horizontal axis. It will give you the motion of object in vertical or horizontal direction. But as we want to find out the movement of box along the inclined plane, it will be a lot easier to take the inclined plane as horizontal or x-axis and the plane normal to inclined plane as y-axis. Now let's quickly find out all required data for calculation. Reaction from the plane RP acts normal to the plane and makes 90-degree angle to x-axis. Self weight is equals to mass of object multiplied by gravitational acceleration g. In our case, mass of box is 50 kg multiplied by g, which is 9.81 meter per second square equals to 490.5 Newton. Now let's find out angle it makes with x-axis. As we discussed, weight W acts vertically downward making 90-degree angle to ground and ramp makes 30-degree angle to ground. So if this is a triangle, angle of W with x-axis is 90 minus 30 equals to 60 degree. Now it is asked to find out resultant force acting on box, which can be solved by two analytical methods. One is method of resolution and another is by using law of parallelogram. Let's start with method of resolution. In this method, first step is to find out components of each force along selected x and y axis. Reaction Rp makes 90-degree angle to x-axis. So x component Fxr will be Rp cos 90 equals to 0 and y component Fyr will be Rp sin 90, that is Rp. Similarly, weight W makes 60-degree angle with x-axis. So x component Fxw is W cos 60 and y component Fyw is W sin 60. Now equation of resultant force is under root Rx square plus Ry square. Rx and Ry are summation of horizontal and vertical components of all forces respectively. But box is moving on inclined plane only and is not moving in vertical direction. We can say that the box is in equilibrium along y-axis. It means that all the forces acting along y-axis are such that resultant force Ry is 0. Put Ry is equals to 0 in above equation and we get resultant force R is equals to Rx. There is only one horizontal component and that is W cos 60. So Rx is equals to W cos 60 and resultant force R is equals to 245.25 Newton. Let's solve the same problem with alternative method by using law of parallelogram. If given two forces are two adjacent sides of a parallelogram, resultant force R is the diagonal passing through intersection and the equation to find resultant is under root f1 square plus f2 square plus 2 f1 f2 cos phi. Here f1 is reaction Rp, f2 is weight W which is equals to 490.5 Newton and phi is the angle between Rp and W which is 60 degree plus 90 degree equals to 150 degree. Now the only missing data is Rp. As we already discussed, box is in equilibrium along y-axis and so summation of all components along y-axis is 0. Components along y-axis are Rp and W sin 60 as we calculated in first method of resolution. So Rp minus W sin 60 is equals to 0. Put all values and we get Rp is equals to 424.78 Newton. Now put all values in equation of R and we get magnitude of resultant force along inclined plane equals to 245.25 Newton. So both methods give same results. You can use any one of the methods if not specifically asked. To find acceleration, use equation F is equals to ma, where F is resultant force acting on a body, m is mass and a is acceleration. Put F is equals to 245.25 Newton, m is equals to 50 kilogram. We get acceleration a is equals to 4.9 meter per second square. Let's solve the problem if some of the conditions are changed. In first problem, box was moving in downward direction along the inclined plane with some acceleration. Now for second numerical, the problem statement is to prevent this downward movement and to hold the box in position, how much horizontal force has to be applied? Also find reaction RP. Now this small statement has changed the whole scenario. We want to hold the box in position, which means that force of such an accurate amount should be applied so that it will not stop only the downward motion but also will not make the box move in upward direction. Box is neither moving in horizontal direction nor in vertical direction, so this is the problem of equilibrium where resultant force of all the forces acting is equals to 0. Here external force F is acting in addition to the plane reaction Rp and weight of box W. And this is the free body diagram. Drag force F and reaction Rp so as to place their tails at center. Now find out angles all the forces make with x-axis. External force F is applied in horizontal direction. As we have selected the inclined plane as our x-axis, this angle will be same as angle the horizontal plane makes with inclined plane, that is 30 degree. RP makes 90 degree and W makes 60 degree angle to x-axis as we discussed in first problem. There is no change in angles of these two forces. Now there are two methods to solve numerical of equilibrium. One is by using equilibrium equations and another is by using Lami's theorem. Let's start with equations of equilibrium. If a body is in equilibrium, resultant force R is equals to 0. Thus, the components of resultant force along x-axis and along y-axis are also equals to 0. These two equations are called the equations of equilibrium. Here x component Rx is summation of horizontal components of all the forces. Similarly, Ry is summation of vertical component of all forces. So the first step in this method is to find out x component and y component of each force. Reaction Rp makes 90 degree angle to x-axis. So x component Fxr is 0 and y component Fyr is Rp. Similarly, weight W makes 60 degree angle to x-axis. So x component Fxw will be W cos 60 and y component Fyw is W sin 60. Third force F makes 30 degree angle to horizontal. So x component will be F cos 30 and y component is F sin 30. Now, according to equilibrium equations, summation of all horizontal components should be equals to 0. So, F cos 30 minus W cos 60 is equals to 0. Here, Fx and Fxw are in same line but are in opposite direction to each other, so they will be subtracted. By putting values of W cos 30 and cos 60, we get F is equals to 283.19 Newton. Similarly, summation of all vertical components is equals to 0. So, Rp minus F sin 30 minus W sin 60 is equals to 0. Put all values and Rp is equals to 566.38 Newton. Now let's solve same problem with another method, that is using Lami's theorem. For this method, the very first step is to find out angles between adjacent forces. The angle between forces Rp and F is 90 degree plus 30 degree is equals to 120 degree. Angle between W and Rp is 90 plus 60 is equals to 150 degree. Similarly, angle between forces F and W is total angle between positive and negative x-axis, that is 180 degree minus 30 minus 60 equals to 90 degree. Now, Lami's theorem states that if three forces are acting on a body, each force is proportional to the sine of angle between other two forces. Let's say first force is F and it is divided by sine of angle between W and Rp, that is sine 150. Second force is W and it is divided by sine of angle between F and Rp, that is sine 120. And the third force is Rp and is divided by sine of angle between F and W, that is sine 90. Then all these divisions are equal. Now the magnitude of W is known to us and magnitudes of F and Rp are to find out. So let's compare the equations of F and Rp with W individually. After putting all values, we get F equals to 283.19 Newton and Rp equals to 566.38 Newton. You can observe that both methods give same results.